Hello everyone. In this video, we are going to explore the full disk encryption using LUKS, which stands for Linux Unified Key Setup. I have already written an article which captures the entire step to encrypt a new hard disk partition. I will be using the same set of commands in this particular video, so if you need more details, you can always refer this particular article. I will be leaving the link of this article in the description section. Before we start and move on to the next steps, you have to understand this article has to be followed by only those users who want to encrypt a new hard disk. If you are looking for steps to encrypt an existing partition with some data on it, then you should not follow this article because we will be wiping off the complete data from the partition and then we'll be going ahead with the encryption. So your existing data will be completely lost. Okay, so now that the scope is clear, let's move ahead and start with the demo. This is the setup which I will be using for the demonstration. This is currently running on Ubuntu 24.10 as a VM on an Oracle VirtualBox. Most of the commands what we will use would require sudo or root level access. Okay, so let's get started. Since we will be using cryptsetup for performing the LUKS encryption, so just make sure that this tool is installed for you. In my case, the tool is not installed, so first I'll go ahead and install this tool. But before that, let me update my repositories. Once the repositories are updated, I'll just go ahead and install the package. This will go ahead and install all the package required for performing the LUKS encryption. Now that the package is installed, let me re-verify. I will be using cryptsetup 2.7.2, which is from LUKS 2. Now that cryptsetup is installed, let's verify the available disks on this system. Currently, I have two disks. One is SDA, one is SDP. SDA has 3 partitions, which is currently used for my system, while SDP is the additional device I have added and I will be performing the encryption on SDP. Before we start, let me perform some wipe operation. This command removes any existing file system signatures or partition table information from the disk. Next, I will use dd command. This will write 100 megabytes of zeros directly to the beginning of the disk. Now, why are we doing this? Because many critical metadata structures like partition tables, boot sectors, or even LUKS headers leave at the beginning of the disk. By doing this, we are making sure that there are no traces of old partitions or encryption headers, and they are fully wiped out before we actually start with the new encryption procedure. Next, we will go ahead and create a new partition on our device. And for a new partition, you can also choose to skip this step if you intend to encrypt the entire disk. But in my case, I'll go with the partition. P for primary partition, I'll just use the default values to use the complete sectors available. Use P to print the existing partition which has been created now. W to write the information to the table. Next, we can use part probe command to write the changes to disk. Now, since we have created the partition, let's re-verify using lsblock command. As you can see, now I have a new partition available inside dev-stp as dev-stb1. Now that our partition is created, let's go ahead and encrypt this partition. We will be using LUKS format to encrypt this dev-stp1 partition. As you can see on the screen, there are a couple of parameters which can be combined with cryptsetup LUKS format, which gives you additional options such as the type to use, the sector size, the algorithm to use. So based on this, you can decide the kind of security which you want to add while doing the encryption. For my case, I'll be using this particular command to perform the encryption. It is asking me for a confirmation whether I want to proceed or not, so I'll just hit yes. It is asking for a passphrase. At this stage, you can give any passphrase. You will always need this passphrase to access the encrypted device going forward, so make sure you remember the passphrase. Next, let's try to unlock the encrypted partition. For this, we will be using LUKS open, and over here we have to give some kind of mapper name which will be used to access the device going forward. We can use a name like my encrypted disk. This can be any name, doesn't matter. It will again ask for the passphrase which we set just some time back. Okay, so now the mapper is created. We can verify the same by going inside mapper field As you can see, I have a new mapper available here, which is mapped to the dev STP1 partition, which we have just encrypted. Next, now that we have a mapper available for us for usage, we have to format this mapper before we can use. Now, either you can format it at this stage itself, or you can create a logical volume. So in my case, I'll be creating a physical volume out of this mapper so that I can create a logical volume later. So first, let's go ahead and create physical volume. Next, we'll go ahead and create volume group. Next, we'll go ahead and create LVM. I want to use the 100% space available, so I'll use this. Otherwise, you can also maybe give the exact size you want to use for your LV. At this stage, we have our LVM created. We can verify the same over here. So this is the LVM which is backed by the LUKS encrypted device. Next, we'll go ahead and assign a file system. I will be assigning ext4. Done. Next, we'll go ahead and create some partition which can be used to access our LVM. Let's now next mount our partition. Next, let's verify whether the partition is successfully mounted. As you can see, now our partition is successfully mounted. Now at this stage, we have created a file system which can be accessed for performing read and write operation on top of a LUKS device. Next, the question would be, how do we auto mount this particular device as part of a normal reboot operation? So let's go ahead and cover those steps. Let's use this command to create a key file inside the root folder. Next, we will restrict the permission to this particular key file. The file is secure and only root can access this particular key file. Next, we'll go ahead and add this key to the LUKS. This is the same passphrase which we had given earlier to secure our dev STP1. Once it is added, we can re-verify the same using LUKS dump. As you can see, now I have another key slot added over here which contains the key file which we just created above. Next, we have to update our crypttab. This is available inside etc. This file basically tells Linux how to unlock encrypted devices during boot up stage. Now the overall agenda for us is to also automatically decrypt our dev STP1 partition during boot up stage so that it can be mounted and accessed automatically. So we'll have to work with this file. Let's check the content of this file. The first section will contain the mapper name which we have created earlier, that is my encrypted disk. This contains the source device which is dev STP1 for us, but we can also use the UUID of that device. This contains the key file location which we had just created some time back. The last section determines the type of the encryption module what we have used. In our case, it is LUKS. So let's generate a UUID for our device. This will be the UUID which we are going to use in the crypttab file. This contains the mapper name. This is our UUID. This is the key file path and the module which we have used. Let's save this file. Now that we have updated the crypttab file, next we have to update the fstab file. This is used for mounting any particular file system during the boot up stage. First, we have to give our LVM location. Next, the target path where the file system has to be mounted. Next, the file system type, defaults 02, because you want this file system to be checked after all the root partitions are mounted. Let's save this file. Now, since we have updated the crypttab files, we have to update the initram as well. Once initram is updated, we can go ahead with the reboot. As you can see, the system has come up properly without any prompts. We'll reconnect to the system. Let's verify whether our partition is properly mounted or not this time. As you can see, the encrypted device has been successfully mounted without any password prompts. So I hope this video was helpful to you. Stay tuned for more similar articles. Thank you.